Hi everyone, welcome to the demonstration of vChain system. vChain is a blockchain system which ensures query integrity. In this video, I will introduce how vChain guarantees query integrity by demonstrating the verifiable query operations. In a blockchain system, if a user hopes to query the blockchain database, what should he do? The first solution is to download a full copy of the database and process the queries locally. This way can guarantee the integrity of the queries, but the cost for storage, computing, and bandwidth resources will become very high. The second way is to become a light node, which maintains block header information only and outsource the queries to a service provider. Service providers are full nodes maintaining full copy of the database. This way will reduce the cost a lot, but the data integrity couldn't be guaranteed, since a malicious service provider may send incorrect results to users. Therefore, the key issue is how to provide query processing with integrity assurance. Data integrity in query processing is an important issue. A service provider may become malicious due to different reasons. For example, it may be compromised by attackers, or it hopes to maximize its own profits. Data integrity has two security criteria: soundness and completeness. First, none of the returned results have been tampered with, and all of them should match the query condition. Second, all the valid data should be returned. No valid result is missing. To solve the problem mentioned before, we developed vChain system. Here is the system model of vChain. There are three parties in vChain system. Miner is a full node which constructs consensus proofs and appends new blocks to the blockchain. Service provider is a full node. When a user outsources a query to the service provider, it will return the results with verification object to the user. Query user is a light node, which uses the VO and block header to verify the integrity of the query results. Next, I will demonstrate the verifiable query operations in vChain system and show how user can detect falsified results when the service provider is compromised. First, let's have a look at the query lifecycle. Here is the user interface. A user can send a query request on panel 1 by entering the start and end block, the numeric range, and Boolean condition. After the user clicks the Submit button, this query will be sent to the service provider and displayed in the service provider dashboard. In the service provider dashboard, statistics about query performance, such as query response time, verification object size, and verification object classification will be illustrated. Besides, received queries and block header information will also be displayed. For the new received query, an honest service provider will return the correct result. In the simulation, clicking the Return button will send the correct result to the user. Once receives the result, the user will firstly do verification using VO and block headers. A pass stamp indicates that verification is successful. Verification time, VO size, and result objects will be shown on panel 2. For better insights, vChain user interface provides VO information and visualization. Panel 3 shows the verification objects with their node types and mismatch condition. Queried blocks will be illustrated on panel 4. Blue blocks do not contain the result objects, while pink blocks contain the results. The red arrow here means blocks from 22 to 26 share the same mismatch condition. Clicking a block will show the detailed authentication data structure. Also, blue nodes indicate that their children do not contain the results. The purple nodes indicate the result objects. Clicking the nodes will highlight the corresponding result objects or verification object. This is the query lifecycle. Next, let's look at the first simulation of attack detection. The malicious service provider destroys the completeness of query result. In the simulation, service provider can click the attack button to preview the results. Assume it removes the object 53 and generates a fake disjoint proof for the object. The completeness of this query is destroyed. Then it clicks Return button to send the incomplete results to the user. User would find the incompleteness during the verification procedure and indicate the verification failure. The failure reason would be identified on panel 4. Here, the disjoint proof for the node 152 is not correct, because the service provider has removed the corresponding object. In the second simulation of attack detection, the malicious service provider destroys the soundness of query result by modifying the result objects. It first removes the object 52 and then add a new object with the same object ID, block ID, and set attribute, but different price. For example, it changed the price from $142 per day to $152 per day. Note that 152 is out of the query condition, which is from 120 to 150. Then it returns the results to the user. User would find the unsoundness during the verification procedure and indicate the verification failure. The failure reason would be identified on panel 4. Here, the modified object is invalid since the price is out of the query condition. This is the end of the vChain demonstration. Thank you for your watching.